So welcome students, we have covered almost all of geometry that was needed, most of it, followed by some say, stuff regarding polygons that was effectively part of geometry. Yes, in the previous class we did trigonometry. The purpose of going through trigonometry was to make you aware of the formulas that would be required in dealing with the situations that we encounter in IOQM. What is important to understand is that you will learn the formulae that were discussed in the previous class only by practicing substantially. As you would have seen that there were a lot of formulae, and in solving questions regarding triangles, and as we will move on quadrilateral stuff, it will not be that convenient unless you have practiced to remember them or to write the correct expression, correct formula as and when needed. And therefore, it is my sincere request. I am very hopeful that you would have followed the advice that I gave you in the previous class, that please do practice those problems where you are able to use the formulae of trigonometry. Okay. In the class, we also started sine law. Okay. In the previous lecture at the fag end, we started with sine law and we said A by sine A is B by sine B is C by sine C. Okay. And then whatever it was. Fine. And then we said extended sine law, what? That this is equal to 2r. We did some problems based on it. Okay. Let me refresh your memory by doing one or two more problems. Okay. And then we will move on to cosine law and other things that would be needed. Okay. So at the very beginning, I said that in solving problems, please use sine law insofar as solving lot of problems of notion where angle and side simultaneously are given, and the angles are not angles. Somebody last class we solved a problem which had an angle of 19 degree. So those are the angles that geometrically even we are not able to draw, and simultaneously they are ratios and stuff we don't know. So we hope that by applying trigonometry there is a chance that we are able to deal with them in a much better and convenient manner. Okay. Now I am those students who missed the last video, please go through it so that you know how did we prove it, how did we prove it. That was done at the last 15 minutes of that lecture. We introduced sine law. Fine. So while solving problems, it is advisable that you use sine rule as and when needed. Say in trigonometry, if I ask you a question like this, this is triangle ABC. And we take a point inside the triangle. Suppose this angle is theta, this angle is theta, and this angle is theta. We have taken a point P such that this is the situation. Okay, and somebody is asking find cot theta upon cot A plus cot B plus cot C. Or we can give you the triangle ABC, angles of ABC, and we can find, and we are asked to find this angle theta. That is how generally, let me first tell you, then I'll tell you what will be the case. Okay. Now, in situations like this, if we are not able to proceed geometrically, it is advisable that we use sine rule as a de facto method that we apply is sine rule. So, how do we start? This angle is theta. This is A minus theta. This is B minus theta. This is C minus theta. Okay. So, these sides are C, A, now here we can say PA upon PB. That can be done, or let us take AB. Let PB be the common thing, PA. So PB upon sine theta is C upon. Can you tell me what this angle is? This is B minus theta, this is theta. So sum of these two angles is B. So this is nothing but A plus C. Sine A plus C. Now let us take this PB only. PB upon sine C minus theta is equal to, this is C minus theta, this is theta, so this would be, as in the previous case, A plus B. This is A upon sine A plus B. The purpose of introducing PB on both occasions was that now we can find PB from this and equate, or we can simply divide these two. So if we divide these two, PB gets cancelled out, and what do we get? Let us write in the next page, sine C minus theta upon sine theta is equal to, you can write sine A plus C is sine pi minus B, isn't it? Sine pi minus theta is sine theta. This is C upon sine B. A upon sine C. A upon sine C. Now C upon A is sine C upon sine. So if you are able to see, it is sine square C upon sine B sine. Okay. Now, because you want cot, you want sines in the denominator. Sine C minus theta upon sine theta sine C is equal to sine C upon sine B sine. What is sine C? Since in the new denominator you have A and B, we will write this as sine of upon sine B sine. and sine pi minus theta is sine theta. So this is sine A plus B upon sine A sine B. The formula for sine A minus B is sine A cos B cos A sine B. This is sine A cos B cos A sine B. Okay. So sine C gets cancelled out, you get cot theta. Here sine theta gets cancelled out, cot C is equal to C. Sine A gets cancelled out, you get cot B. Sine B gets cancelled out, you get cot A. So cot theta is cot A plus cot B plus cot C. If the triangle is equilateral, corresponding point will be the centroid. Okay. Fine. So this is the use of sine rules. So whenever you are not able to think of a geometrical way to proceed in the problems, a very good way to deal with such problems is this. Now, because of this fact, what did we prove? Here also somebody may ask you, show that cosec square theta is in the previous problem. So how will we deal with it? We had proved the fact that is available to us is this. Fine. Now if we square it, what do you get? Plus 2 times cot A cot B now. If you remember, what we learned in the last class was, in a triangle, tan A plus tan B plus tan C is tan A, tan B, tan C. I hope I very specifically told you to keep this in mind. In a triangle, sum of the tangents is equal to product of the tangents. So, what do you get now? If we dividing both sides by tan A, tan B, tan C. So if you divide both sides by tan A, tan B, tan C, here you will get 1. And what are you going to get on the left hand side? Tan A gets cancelled out, cot B, cot C plus cot A, cot B. So this is nothing but 1. So what you have got is cot square theta is cot square A plus cot square B plus cot square C plus 2, and you can now very easily see cot square theta plus 1. If you add 1 on both sides, you will get 2 here, and you will distribute that 3 each one of these cot squares. So cosec square theta is cosec square A plus cosec square B plus cosec square C. So this is how we use trigonometry, sine rule in things like this. Okay. Let me give you one more example. Okay. Uh, so in a triangle, sides are in AP. In a triangle, sides are in AP, and the largest angle is twice the smallest. And the largest angle is twice the smallest. If sides of the triangle are natural numbers, find least possible area. Find least possible area of the triangle. Okay. Unfortunately, there is some lag in the board. Some issues are there. Okay, so I have deliberately written the whole expression very slowly, because otherwise it was all getting haywire. Fine. Here also, let us say sides of the triangle are A minus D, A, A plus t. The smallest angle is say theta. So this would be, the largest angle would be 2 theta. So the remaining angle is pi minus 3 theta. Okay. What I am trying to convey is that the moment you see the data, the only possibility that works out is trigonometry, and a viable way turns out to be sine rule. So please keep these things in mind. Okay. Now what do we get now by sine rule? Let me write in next page. By sine rule, A minus d by sine theta is A upon is sine 2 theta. Okay. So now if we, from these two, what do we get? Sine 3 theta upon sine theta. What is sine 3 theta? 3 sine theta minus 4 sine cube theta. So 3 sine 3 theta is 3 sine theta minus 4 sine cube theta. So this is one thing that you get. If we take these two, what do we get? Sine 2 theta upon sine theta. Is what is this? Sine 2 theta is 2 sine theta cos theta. So this is 2 cos theta. So incidentally, we here have sine square theta. So what we are going to do is that here we will write this as A upon A minus D is 3 minus 4 into 1 minus cos square theta. So this is 4 cos square theta minus 1, 2 cos theta whole square. So what is 2 cos theta? A plus D upon A minus D whole square. So what you are going to get is denominator is, and what will be the numerator? A plus D whole square minus A minus D whole square. 4A D. So A and A gets cancelled out. You have A minus D is 4B. So A is 5D. So sides are 4D, 5D, 6D. Okay, I think now since we gave our sides as natural numbers, we have to find the least possible area. So we take our sides to be for least possible area. The sides are 4, 5, 6. Okay, for least possible area, the sides are 4, 5 and 6. So that is, if you want, I think that this calculation is very trivial. The important part was this. Another beautiful problem of the same genre that appears, in fact, it appeared in JEE Advanced 2. Unfortunately, when solution of triangle was removed from the syllabus, was sides are in AP and the largest angle is 90° more than the smallest angle, then ratio of sides. Okay. In the language of this problem, only this thing needs to be changed. Okay. The largest angle, okay. Let me just refresh you. Question is, sides of a triangle are in AP. And largest angle is 90° more than the smallest angle. Find ratio of sides. Same thing. I hope you are able to understand. A minus D, A plus D, just as we did in our previous problem. If this is the angle theta, the smallest angle, the largest is 90 plus theta. So this is 180, 90 plus 2 theta, total sum is 180, so it is 90° minus theta. Agreed? Now we have to use the sine law. A minus D by sine theta cos 2 theta is upon cos theta. Getting it? Sin 90 minus 2 theta is cos theta. Sin 90 plus theta is cos theta. Now, in the previous, because most of them I think were sine, it was easy to deal with them. Cos 2 theta, if you remember the formula, what is the formula for cos 2 theta? Cos square theta minus sine square theta. So somehow we have to plug in this expression. So it is cos plus sine into cos minus sine. So we try to create cos plus sine. So I think by componendo, we can say just add these two. So 2a upon cos theta plus sine theta. We can subtract it, it is 2d upon cos minus sine. Now, if we plug in these two, cos 2 theta. So, what is half is equal to, you can see a upon 2a is cos 2 theta upon cos theta plus sin theta. What is cos 2 theta? Cos square theta minus sin square theta, which is cos plus sin into cos minus sin. Cos plus sin gets cancelled out. You get half is cos theta and first and last. Okay, in a similar manner, because here we have minus, so what will be left would be cos plus sine. Now, how to get rid of cos sine here? In this a minus d a plus cos square plus sine square is 1. So we can what we can do here to get rid of theta, square and add. Square and add. What are you going to get? 1 by 4. What is this? 7 by 4. 2 minus 1 by 4, 7 by 4. A square is d root 7. So, root 7 minus 1 is to root 7 is to root 7 plus. Just an algebraically same thing, only the difference was in terms of the notional thing that we had to use. It was sine rule. But then, since trigonometry involves a lot of expressions subject to a certain situation, what are the expressions that would be helpful? In the previous question, we used sine 2 theta, sine 3 theta. Here we use cos 2 theta. So, depending upon the angles involved, therefore, it is very necessary, as I have been telling you at the right from the beginning of the previous video, that it will be necessary to remember the formulae of trigonometry. They must come naturally. Otherwise, see, if we are not able to express these formulae, it will be very difficult. You can see these formulae play a very trivial part insofar as problem solve is concerned. It is presumed that we know these formulae and we have to just at the appropriate juncture, we are just applying it. Knowing the formula is not an issue. The issue broadly appears that which one to use, how to do manipulation, as this one we did here. So such stuff is expected from us. So please be ready for that. Okay. Just I think these are questions from SL Loni. Even in JEE Advanced, they ask questions from SL Loni. Okay. Almost always the same. So a fantastic book, and therefore I told all of you to practice from that book, so that you are able to write the formulas and when needed. The best part about Loni is that, or in this standard text, is that there are a lot of questions on single formula. So if you practice enough, you will be able to deal with it very, very, very efficiently. Whether you are giving your school examinations, whether you are appearing in Olympiad, whether you are appearing in JEE Main, whether you are appearing in JEE Advanced, you will see that almost all the problem have the flair of the questions that are there in SL1. That is the beauty of the book. Okay. Now, moving ahead, let me also tell you cosine law and projection formula. Okay, so cosine law says cos A is and I think in a similar vein you can say, or you can write, somebody may write it as A square is B square plus C. People may write it like this, people may write it like this. So sine cos you can write, say, suppose I draw this already. This is C, this is C cos B. Okay, this is C sine B. What is this? A minus C cos. Now apply Pythagoras theorem. C square sine square B. Square of the plus base square is equal to B square. So this is C square sine square plus C square cos square, you get C square. B square is this. You can draw altitude from B and get the same result. This is basically the expression we have obtained for cos B. We could have done it the other way around. We could have said this is B cos C. So this is A minus B cos C. This is C sine B. In the sine rule, you can say is B sine C. Okay. Now, insofar as projection formula is concerned, I think it is very easy to see that if this is C cos B, this is B cos C. A is what? B cos C plus C cos. And in similar way, we can write B is C cos A and C is A. Fine. So this is called projection formula, this is cosine law. So two formulae which would almost be sufficient in dealing with the problems that we will encounter, almost be sufficient. To introduce a variable on your road would invariably apply either using sine rule or cosine law. Barring this, whatever we come across in solution of triangle, you will see that they will primarily be stuff like, if something is provided, if somebody says this is circumradius, if somebody says this is angle bisector, so then those formulae of trigonometry, if we are applying trigonometry, then only they get introduced. Either they are asked or they are provided. Otherwise, on our own, if we have to use variables and stuff like that, we generally prefer using sine cosine law. Okay? Now, if you look at it as how are you going to use cosine law? So, when angles are asked, the sine law generally, cosine law is generally preferred because sine A is root 3 by 2. So, you may have an issue whether the angle is acute or obtuse. But otherwise, you are able to, in cosine law, you are able to easily gauge what is the situation because second quadrant cos is negative. Very simple question is, if A plus B upon 10 is B plus C upon 11 is C plus A upon 12, find cos A. So A plus B upon 10 is, this is given. So what we do generally in this type of problems, let this be some lambda. So a plus b is 10 lambda, b plus c is 11 lambda, c plus a is 12 lambda. You simply add, sorry, 33 lambda by 2. C is 11 lambda by 2, isn't it? 12. 9 lambda by 2. Sides are in AP. Cos A now we can very easily find. This is B. This is A. So what is cos A? Lambda square will get cancelled out. B square plus C square minus A square. To BC. So at the very beginning we could have got rid of this 4. Even though I wrote and then cancelled, but it is only an issue of proportionality. So we could have taken the proportion 13 is to 11 is to 9. So what is this? 169 minus 121, 48. 48 plus 81, 129. 117 into 2, 234. So this is cos. Not a reasonable number, but so be it. Okay? Use of cosine law. How else? Let me give you one more problem where we are using cosine law simply. Yeah. See, in a triangle, a square plus b square is 11c square. Okay. Find cot c upon cot a plus cot. Information being provided in this manner is indicative of the fact that a possible way to deal with the situation would be cosine law. Okay. So let us see what is cot A. What is cot A? Cos A by sine A. What is cos A? We have just gone through the formula. B square plus C square minus A square upon 2BC. Two BC sine. Okay. If you recall, area of the triangle we wrote as half BC sine, or half AB sine C, or half AC sine B. So this is B square plus C square upon 4 delta. This is B square plus C square minus A square upon 4 delta. Okay. Now we see what to do. Similarly, what we will get cot B as C square plus A square upon 4 delta, and similarly for cot C. Okay. So cot A plus cot B. 4 delta, you can see what it turns out to be, cot C. So cot C is upon 4 delta. 4 delta will get cancelled out, cot A plus cot B. A square gets cancelled out, B square, 2C square. So is 11C square okay. So this was some where we could very easily conceive the fact that this expression was required to deal with the situation. Now, in some cases, suppose I say in triangle ABC, say side A, or rather I would say side AB, BC is suppose say 6, CA is suppose 8, and angle ABC is say 60 degree. Find possible value of AB. So simply by cosine law, cos B, okay, cos B is half is C square plus A square minus B square upon 2 into C into this is cos AB C. B cos B is C square plus A square. A square is 6. 2 gets cancelled out. You get 6C is C square minus 36 minus 64 is 20. C square minus 6C minus 28 is 0. You can see one of the values of C will be positive and one will be negative. We will take up the positive. 36, 112. 148. So 148 30 3 plus root 37. 3 minus root 37 is ruled out. Now, if we just shift these two, suppose this is 8 and this is 6. Are you able to see that the equation is going to be 6C is C square plus 28. So, probably in general you get a quadratic, there is a possibility that you get two triangles. Okay, the data can be appropriately taken. You can consider it like this, okay, that see, you are given a side, this angle is given to you as 60 degree, okay. CA, BC. BC is 8, isn't it? BC is 6, CA is 8. So if this is A, BC is also given, okay. And BC and CA, okay. No. BC and CA. What is BC? 6, okay. So if this is 6, okay. So what you have to understand is that from this point as center, C as center, what you are doing is you are drawing a circle of radius 8. Suppose you know the radius has to be at least, see, 6 sine 60 degree, that is 3 root 3. The radius has to be greater than 3 root 3. That means this has to be greater than, this side has to be greater than 3 root 3. 3 root, if you take something greater than 3 root 3, you will get two triangles. The moment you take your side to be greater than 6, okay, you are going to get a circle like this. So this point is ruled out. Only this triangle is something that we are getting. So this is 6. This is 8. And this is 3 plus root 30. So that is 3 minus root 30. So had our side, had this side been less, had this side been say 3 root 3, the 17, 3 7. Suppose BC is 6, CA is 11 by 2. In that case, you would have got 2 triangles, because the moment you say this side is greater than 6, you only get 1 triangle. The idea is not to remember these stuff. The idea is to always apply cosine law. You get a quadratic. If both roots of the quadratic are positive, you get 2 triangles. Sometimes you are asked question on what are the sort of triangles that you are going to get. Okay, so that we will take up in our next class, sine, cosine law. Then we will move ahead with other stuff of solution of triangle. Primarily, this is sine and cosine law are to be used in solving problems. Every other thing that we read post this would just be an expression or a formula that would be utilized if it is asked or if it is provided. On our own, we generally, or I would use the word always, use sine, cosine. Okay, so I am thankful to all of you to be with us for such a long period of time, and I hope you would have gained from our session in general, and in particular you would also have benefited from this session. Thanks a lot.